Hello and welcome. In this video, we want to find the Norton equivalent of this circuit through the terminals A and B, and it will look something like this. The first thing we want to do is we want to find the value of I of n, then we proceed to find the value of R of n. Now, to find the value of I of n, that is quite simple. What we just want to do is that we want to go to the open circuit terminals, then we want to connect a short circuit across it. I of n is also known as the short circuit current. Now, the current that flows in this short circuit would be I of n. Now, what we just have to do is determine the value of current flowing in this short circuit. We can simply use mesh analysis for this, and this would be our first mesh, and it will have a current I1. Mesh 2, we have a current I2. Mesh 3, we have a current I3, and mesh 4 would have a current I4. Now, notice that the direction of I4 is the same thing as the direction of IN, so we expect IN to be equals to I4. This would infer that the current that we are actually interested in finding is I4. Now, looking at mesh 1, it's quite easy to determine that I1 is equals to 3 amperes because there is a 3 ampere current source in the mesh, so we say I1 is equals to 3 amperes. We can then proceed to mesh 2 and write a KVL equation in mesh 2. So let's say M2. Then we say we have I2 minus I1 flowing in this 150 ohm. So we have 150 to I2 minus I1. Then plus 10 into I2 minus I4, okay, then plus 40 into I2 minus I3, all equal 0. We soon have it that 200 I2, okay, minus 40 I3 minus 10 I4 equals 150 I1. Recall that I1 is equal to 3 amperes, so we can say 150 times 3, 450. We can call this our first equation. We can then proceed to mesh 2, and in mesh 2 we would have mesh 3. Mesh 3, let's say M3, would have 40 into I3 minus I2, 40 into I3 minus I2, okay, plus 8 into I3 minus I4, okay, minus 300 equals 0. That is the KVL equation in the third mesh, and it will all equals to 48 I3 minus 40 I2 minus 8 I4, all equals 300. We can call that our second equation. Then we can proceed to the third mesh, where we write the equation the fourth mesh, M4, where we write the equation as 8 into I4 minus I3 plus 10 into I4 minus I2, all equal 0. Then we can rewrite that as 18I4 minus 8I3 minus 10I2 equals 0. We can call that our third equation. And then proceed to solving these three equations simultaneously to find the value of I4. And with that, we arrive at the value of I4 is to be equals to 8 amperes. That is the only current we are interested in, because we know that IN is equals to I4, as I stated earlier. Now, the next thing to do would be to find the value of Rn. Now, finding the value of Rn requires us to put off all the current sources and voltage sources. Now, putting off a voltage source leaves a short circuit, and putting off a current source leaves an open circuit. And for that reason, we end up with a circuit like this, where R of n would be the value of resistance measured when we connect an ohm meter across the terminals A and B. Now, R of n would be equals to, we have these two resistors in parallel, so we can say that 40 in parallel with 8. Okay, then we also have these two that are in parallel. We have them in series with this 10 ohm resistor, so plus 10. Then we expect this entire system to be in series with this 150, to be in parallel, sorry, with the 150 ohm resistor. 150. And when we simplify this, that would be what the value of R of n is. Now, 40 in parallel with 8 would be 40 times 8 divided by 40 plus 8, and plus 10, all in parallel with 150. And then this would be equals to 20 over 3 plus close bracket, all in parallel with 150. Then this would be equals to we have 50 divided by 3, okay, in parallel with 150 ohms. If they are in parallel, we would have 50 divided by 3 multiplied by 150 divided by 50 divided by 3 plus 150, and this would be equals to 15 ohms. So we know that the value of R of n is 15 ohms. So we can just put it in here that I of n is 8 amperes, and R of n is 15 ohms. And this is the Norton equivalent of the circuit. Thank you for watching. Don't forget to hit the like button and subscribe. See you next time.